And our final day for lesson 15, determining the number of solutions for a system of equations. We're just putting everything together. So number 15, look at the system of equations below without graphing. Explain how you can tell what type of solution each has. So remember, whenever we have a system of equations, we always want to simplify first so we can get a better view of the variable terms and the constants. All right, so the first one, the top one is already simplified. So all we need to do is simplify the second one. So we will distribute, so we will be distributing the 0.25 to both terms in our parentheses. So 0.25 is just a fourth. That's literally all it is. It's a fourth of a dollar, right? So we'll have y equals 0.25 times 2x, which is just a fourth of 2x, which is a half of x. All right, and then we have a fourth of 4, which is just 1. So we've got our two equations, and we automatically notice something. They have the same variable terms, but they have different constants. When you notice that, they have the same variable terms, different constants. And when we say different constants, we now are referring to the y-intercepts. They're different. So when you have that same, and then of course when we're talking about the variable terms, they have the same slope. So when they have the same slope, then but different y-intercepts, then they're going to give us a parallel line or parallel lines, which automatically have no solution. Alrighty, moving on to number 16. Look at the systems of equations in the box at the right. Kevin stated that the equations in the system have the same slope, which they do. They're both 1.5. So there will be infinitely many. Well, when they're infinitely many, every term is supposed to match, right? And that's just simply not true in this system of equations. Not true in this system. All right, but we notice they have the same slope, but different y-intercepts. Well, that matches with number 15, which gave us no solution. All right, so Kevin's statement makes sense on the first part, where yes, for infinitely many solutions, they're supposed to have the same slope, but they're also supposed to have the same y-intercept. Okay, so since it's not true in this system, we can obviously say that Kevin forgot that the y-intercepts or constants must match as well. This system has no solution. All right, and we're going to move on to number 17. Study the graph at the right based on what you see. Write an equation for each line. Substitute the coordinates of the point of intersection into both your equations. Explain why this point is a solution to the system of equations. All right, so both lines cross, or they cross each other at 4, where x is 4 and y is 2. So the solution to the equation is 4 comma negative 2. And we just have to come up with an equation for both. So we need to find the slope and the y-intercept. Y-intercept for the red is at 2. The slope is just, you just make a triangle from one point to the next. It goes down one to the right one. So this slope is negative 1 over 1, which is negative 1. And the y-intercept, which is our b, is positive 2. So the red line's equation is just going to be y equals, both of them will be y equals mx plus b. We have our m, which is negative 1. Then we put our x. And then we have our b, which is positive 2. You can obviously write this a different way. So it'll be y equals negative x plus 2 is for our red. And then we'll go to our blue. Our blue, it starts off at the point -3. So our B is -3, which is our y-intercept. And then we just find 2 points that it goes through, which it obviously goes through that intersection point. To get from the y-intercept to the intersection point, you go up 1 and over 4. So the slope for this one is going to be the rise over the run, which is 1 over 4. So it's just 1/4. So the blue line's equation will be y equals 1/4 x plus -3. So yeah. And then of course we can write that a different way. 1/4 x minus 3. When we look at these two equations, we see that they have different slopes. And when they have different slopes, I mean that they have different variable terms, which I'm just trying to combine the vocabulary we used in lesson 14 with this one. Since they have different variable terms, then that means they will have exactly one solution, which the graph, of course, corroborates because they intersect at exactly 1 point, which was 4, -2. And they also said go ahead and substitute that point into our equations. So x is going to be 4, y is -2. X equals 4, y is -2. So plug it into our equation. So let's do our red and our blue again. So for the red, y is -2. X is -4. I'm sorry, x is 4. So let me rewrite that so it looks better. So we have negative and then put our 4 in plus 2. Well, -4 plus 2 is just -2. True statement. And then do the same thing with our blue here. So our y again is -2. And our x is +4 minus 3. So, oh, that's a 4 there. 1/4 of 4 is just 1 minus 3. 1 minus 3 is -2, which again is a true statement. Okay, so it gives us a true statement for both. So why is this point a solution? Because when we plug it into our equations, into both equations, it gives us a true statement for each. So true statement, which is why it's a solution. All right, moving on to number 18, the 3 parts. Okay, it says use what you've learned to complete the task. So create a system of equations with the following number of solutions. Use the equation below as one of the equations in each system. So the first equation that all 3 are going to have is this one. I'm actually going to erase that. I want to see what this one actually is before we try to match them up or do other things with it. So half of 6x is 3x and half of -8 is -4. So one of our equations is 3x minus 4. Y equals 3x minus 4 and y equals 3x minus 4. Okay, so for infinitely many, you know it has to be exactly the same. So that one's the gimme one. Is so easy. So the second equation has to be y equals 3x minus 4, the exact same thing. And if you want to make it look real fancy, then we'll have what we had at first. 1/2 of 6x minus 8, and then y equals 3x minus 4. Okay, that's what I want here. No solution, remember, is when... Okay, remember, I'll just go ahead and put that off to the side. Infinitely many means every term matches. No solution means that the variable terms or the slopes match, but the constants don't. And when we say constants, we mean the y-intercept. Constants don't. So we know the the variable term is supposed to match, so it'll be y equals 3x. And then just write any other number that's not -4. So like maybe let's say plus 2. Okay, you can put literally anything you want to here. Doesn't matter. So we'll put it exactly how they gave it to us again. 1/2 6x minus 8. And then y equals, oops, probably could write that over there. Y equals 3x plus 2. And then lastly, for one solution, all we're supposed to do is have different slopes. Or when I say slopes, I just mean the variable terms are different. Okay, so all we need is a different variable term, so we're only looking at the 3x. So we could just have that y equals maybe just x minus 4. It could be the same. That's perfectly fine. Ew. Yeah, that could be the same. Alrighty, so we could do that. It didn't say that we had to graph it, so I don't want to graph it, but I will. You can totally graph it to check it yourself as well. So I'll just make part A purple. All right, so they already have the first one graphed. So let's graph the second one. They'll both start at -4 because that's my y-intercept. And then my slope for this one will just be 1. So I'll go up 1, over 1. Up 1, over 1. Okay, so it looks very, very, very close. Oh, my line sucks. Let me write that or draw that a lot differently. Okay. So they cross obviously at the y-intercept. Okay, so it's exactly 1 point. Boom. And that one solution was 0, -4. Crossed at 1 point. And I want to point out that when you have different slopes but the same y-intercept, then that one solution is going to be your y-intercept. Okay, so that's the special time that you're going to have that one solution. So if you have, like I was saying, if you have different slopes but the same y-intercept, then the solution to the system of equations is equal to the y-intercept. All right. Okay, and then B, again, I'll make that one pink. So we already got this first one out there, and I mean, it's the same exact thing. I'm just going to okay, that sucked. It's literally the same line. So same line for the infinitely many, of course. And it's pink, but I mean, it's literally the same line. All right, and then the last one, I'll just make it bright yellow. No solution. We already got the first one graphed. We just need 3x plus 2, so we'll start at +2. And our line, or our slope, is just going to be 3 as well. So go up 3, 1, 2, 3, over 1. Same thing, 1, 2, 3, over 1. And then if you want to go the opposite way, you just do everything opposite. Down, 1, 2, 3, left 1. Down, 1, 2, 3, left 1. So when you put all these together, then you see, did I do this wrong? Looks like I did it wrong. Oh, yeah. Well, then you see they're supposed to be like never touching. I don't know. I guess I must have drawn mine wrong. Let me fix this. Let's see. So again, no solution is supposed to be where you have your variable terms. They do match, but the constants don't. So mine was supposed to be starting at 2 and then go up 3. 1, 2, 3, over 1. 1, 2, 3, over 1. I don't think this is drawn correctly then. So if I have 3x minus 4, okay, so my 1, 2, 3, over. See, yeah, I don't think this one's drawn correctly, or I just did it super wrong. Nope. It's supposed to be like this. So this one is not drawn correctly. I don't know why it made me think I was crazy. But they're supposed to be parallel, obviously, but they're not. And that's okay. but I just want you to know the rules for it. I don't know how this was so wrong, but it is. That line they gave us is super wrong on there, and that's okay because we know we're right in our explanations. Okay, so they're supposed to be parallel lines. Parallel lines there, but you clearly can't see that because they drew it wrong, but it's okay. All right, so that is it for our lesson 15. Please make sure that you've done your workbook pages that go along with this lesson in preparation for our quiz, and of course just to understand system of equations. This is our intro. All right, thank you.